The three components that you're going to need for this small little project, plus a little 3D printed case. Again, you can find this in the comments. And you can find where to buy all of these three things in Banggood. I'll put the description in GitHub as well. So the Nano is just a Arduino Nano with a mini USB connector. Then you have a receiver, 5.8 receiver, and this has to have something that's called the SPI mod, so it allows you to change to all other frequencies. And then you have some small LEDs. Now you can use you can piggyback off the 5 volts from the Arduino, but only up to like I would say 10 LEDs. More than that, and you'll start it won't be good for the Arduino. So small for me is better because I can then have like a pocket version of it to carry around. Just need to connect in the USB in the back. And you need to be able to solder like 9 cables. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. If you buy this one, it already comes with the cables for you to solder. So it can't get any easier than this. And what we're gonna do is to just take the ends out of the cables here. Can even do that with a nail. And you can already see I pre-soldered already 6 cables to the receiver, and they are the RSSI, which I'm using a yellow cable. There's the 5 volts in to power up the receiver. I soldered a red cable. Then there's the ground. I solder like a, what is this? Brown cable. Then I soldered the channel 3, channel 2, and channel 1, and this is used for the Arduino to change the channels in the in this basically sorry, to change the LED color. Change the channels. It will scan for any drone nearby, and then if it finds a frequency, it will change the LEDs to that to the color that was specified for the frequency. Okay, so just gonna go and solder first let's go with the RSSI. So the RSSI is gonna be soldered to A3 on the Nano, and it's clearly marked as A3. And what I do is I solder it just underneath. That's it. Then we're gonna solder the 5 volts for that powers the receiver. And again, it's clearly labeled at 5V and then ground. So we're gonna solder the 5 volts and the ground from the receiver directly to the Nano. And what I do is I solder underneath this one as well. Let me check, where is it? There it is. So 5 volts is on that side. Make sure not to get this part wrong, otherwise you're gonna blow either the Nano or the receiver or both and the LEDs, which won't be nice. I mean, it's not, this is cheap enough that you can buy several of these and it won't really put a dent on your budget. Probably spent more on props. So right now we have RSSI, yellow cable. We have ground, brown cable, and then the 5 volts to power up the receiver, which is the red cable. All connected to the bottom part of the Nano. So I connected that to the bottom part because I wanted to. No, it just makes it easier for me. So now we're gonna we're gonna do the following. We're going to connect the channel 1 to D10. Again, this is clearly marked here on the Nano. And I'm gonna connect it to the top. So again, channel 1 on the top to D10, delta 10. Okay, that's it. Then we're gonna connect channel 2 to D11. And finally, the last cable, we're gonna connect channel 3 to D12. I think that's right. Pretty sure that's right. Then next we have to connect the LEDs, and that's why we soldered this on the bottom, because we're going to connect the LEDs on top. And again, it's 5 volts, the ground, and then the yellow cable is the data. So the data we're going to connect to D5. I'm going to do that on the top. Then the 5 volt and grounds from the LEDs you're going to connect on the top. So 5 volts first, and then the grounds. That's it. That's all you have to do. Then obviously if you want to, you can print a nice 3D thing, but that's, you know, just a little extra if you really keen. I like it. Just put this there. Oh, there was a cable that wasn't soldered properly. Just came off. What was that from? Oh yes. So D10 wasn't soldered properly. We have to resolder it. If you can stress test your cables, especially the 5 volt and the ground, those are kind of the more important ones, because if you don't get those right and they short, you're not gonna have a happy day after that. There we go. Soldered. Okay, put this back. Now the other part, which is the coding. So let's go back to the laptop to see that. Okay, so on the coding side, you have to download and install the Arduino IDE, and the instructions are in GitHub. If you don't have this or you don't know how to do it, then you have to load the ctf.ino code. That should open up the sketch that you have to import to the Nano. Again, make sure that you have the board selected to Arduino Nano and the processor selected to 18 mega 328P, and make sure that the port that you've selected is the correct one. So if you don't know what port it is, just unplug the USB and you'll see one of the ports disappear, and when you replug it back, then you should be able to see a new port appear, so that will be the one. And from now on, it's pretty straightforward. All you have to do is press on the upload button, and this will upload the code to your Arduino. Now there's a couple of things that you need to know. From my experience, it seems that the RSSI threshold is different from receiver to receiver. So something that will work on one receiver doesn't mean that it will work on the next one. So you'll have to go in the code, scroll down until you find RSSI threshold, and modify this value until you find the sweet spot where the quad is going to be close enough that it detects the RSSI, but not as you enter the room where the flag is, and it suddenly just picks it up. I find that a value between 190 and 260, being that 260 is the maximum that I've managed to get, works the best. So for this case, for example, I'm going to try and use the RSSI 224. So if I put a drone next to it and it lights up right away, well, that will be good. But if I still put like I'll reset the system, put the drone like a couple of steps back, restart the Arduino by plugging 5 volts into it, and if it still lights up and it's too far away, then I'm gonna come here back to the code, check the RSSI threshold, and then re-upload the code into the Nano. There's another thing that you can change as well, which is the modes. As I said before, currently the default mode is capture the flag, and that's the mode that's pre-selected. If you want mode 2, which is free for all deathmatch, or mode 3, which is treasure hunt, basically, or scavenger hunt, you can just go to this item here, it says mode 1, and change it to 2 or 3 depending on the mode that you want, and that will be it. So depending on the mode that you have as well, when you power up the Nano, you'll see the lower light, the function light from the Nano blink once or twice or 3 times depending on what mode you are on. Again, I commented everything on the code. If you know a little bit of code, you'll be able to understand what you can change and what you can change. But I think for alpha, this is pretty good. So, without further ado, I think it's time to end this video. And here is the little Arduino that we've just programmed moments ago. Turn it on, lights up. I think you can see the LEDs here on the table. And when we power up a drone, I'll set the RSSI pretty low, so it should start lighting up right away. And it's on blue team, so I think if we change a couple of frequencies higher, it will then change to red team. Voila! Keep in mind, again, this is an alpha. I take no responsibility if something doesn't go according to plan. I did test it already with several Nanos, and it seems to be working fine. But keep in mind that I'm not the programmer. First of all, I learned this only in a couple of days ago, and you know, I wanted to make this for the longest of times, and since no one else did it, I thought I'll just try to learn code and do it myself, and miraculously enough, it worked. And I couldn't help but I couldn't end this video without also appreciating the support for the people that did the base code for what I'm using, which is Chorus RF lap timer. So without that code, I wouldn't even be able to do this. I hope you enjoyed this video. If you did, again, leave a like. Share this video with friends that might like this system. I would like to see people using it. Obviously, that's why I created it for. But mainly, I have to say that I actually created this for myself because I wanted it so badly. But you know, if I can offer something back to the community, I'm happy to. And that's all.